Okay, as promised, here's another graphical example. Here you're given the graph of a derivative. So make sure you read these questions carefully. F is a function defined in the closed interval. F is not shown. The graph F prime is shown. So maybe one way what you might want to do this video is to copy this down, do the problem before I do it, and see how you did. So pause and stop, how it works best for you. So anyhow, the 6 questions we're going to be looking at are finding the critical numbers of F, figuring out where F is increasing and decreasing, the intervals, and then finding the X values of any relative mins and maxes, and then determining the equation of the tangent line at X equals 3. So here we go. The critical numbers are where of F are where its derivative equals 0. This is the derivative of F. You have to figure out where it equals 0. Well, that's right here, and right here. That's where the derivative graph equals 0, thus the derivative equals 0. So the critical numbers are X equals 0, X equals 4, and X equals 6. Now remember those, because if in question number 4 and 5 you're looking for the relative extrema, if you get any of them, they better occur at 0, 4, or 6. So the next question, where is F increasing? F is increasing where F prime is positive. And then the next question, where is it decreasing? A function's decreasing where its derivative is negative. So we can answer both those questions together. So this is the graph of the derivative. We're trying to figure out where it's positive, so I'm going to, it's positive, a graph is positive when it's above the x-axis. So all the values are positive here, and this is the derivative. So the derivative is positive this whole way until you get to 4, and then it goes to negative. But then at 6, it's back up to positive. So those yellow highlighted points are where the derivative is positive, and therefore the graph F is increasing. So the intervals that F is increasing would be 0 to 4, and then again from 6 to 7. F prime is negative where the graph of the derivative is below the x-axis. So you can see that that's really the rest of it from 4, still negative, still negative, still negative, still negative, to 6. That's it. Now we have to figure out where the, oops, I don't know what I'm doing. The next question is to determine where the minima is, and then the maximum. So, as usual, I'm going to justify my answer, just like I did here and here, before I actually do the problem. A minimum happens when the derivative goes from negative to positive. And a maxima or a maximum occurs when a derivative goes from positive to negative. So again, we just look at this graph. At 0, it starts out positive, so nothing changed. You're looking for a change. This graph is, the derivative is positive, as we just talked about in the previous question, until you get to 4. And then it goes to negative. So positive to negative at 4. That would be a maximum. Let's take care of that right now. And then negative, 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 and then derivative goes to positive right here. So negative to positive at 6, which would indicate a minimum. All right, easy enough. So there's one last question. Write the equation of the tangent line to the graph. Let me get rid of all this stuff. At x equals 3. So as usual, what I'm going to do is I'm going to answer the question without even looking at the graph, and then we'll use the graph. I don't know what I'm doing here. Okay, now I do. The answer to this question is as simple as this. This is c. So it's y minus f of c equals f prime of c times x minus c fill in these two blanks. This is the graph of the derivative. So on the graph of the derivative, you should be able to find this, f, the derivative at 3. So let's look at 3. The derivative value is 2. So f prime of 3 equals 2. F of 3, you need the graph of the original function. We don't have it. So somewhere it has to be given. Oh, and look right here. F of 3 is negative 21. So this would be minus a negative 21. And that is it. We're done. So these questions are pretty easy once you understand. Once you get used to looking for the derivatives. Hopefully you're finding that. If you have any questions, let me know.